Bismillahirrahmanirrahim. Assalamu alaikum students. Today I will solve the Cambridge GHZ A-level paper 3, October-November 2022. Now let's start the paper. Question 1. Solve the equation 2 power 3x minus 1 equal to 5 into 3 power 1 minus x. Give your answer in the form ln A over ln B. Now you see here we have to convert this equation in this form. Firstly, we take the logarithm on both sides. Now we can write it as 3x minus 1, that is equal to 5 into 3 power 1 minus x. Now I take the logarithm ln on both sides. Now here you see here ln 2 power 3x minus 1, we use the exponent logarithm rule. In the exponent logarithm rule, you see here that is suppose ln x into power y, that equal to y into ln x. Therefore, we can write it as 3 into x minus 1, 3x minus 1 into ln 2, because the power becomes coefficient. And you see here ln 5 into ln 3 1 power 1 minus x. Here we use the product rule, and the product rule x into y ln x into y, that is equal to ln x plus ln y. Now we therefore the ln 5 into ln 3 power 1 minus x become ln 5 into ln 3 power 1 minus x. Therefore that becomes 3x into ln 2 minus ln 2. Now ln 5 is written as it is, plus now the power of the logarithm becomes coefficient. We write it as 1 minus x into ln 3. Now we simplify it. 3x into ln 2 minus ln 2 equal to ln 5 ln 3 minus x into ln 3. Now combine the x variable. Now you will see here this is 3x into ln 2 plus x into ln 3, that's equal to ln 5 plus ln 3 plus ln 2. That value x is taken as a common, we will get 3 ln 2 plus ln 3, that's equal to ln 5 multiplied 3 multiplied 2. Use the product rule. This is the product rule, and therefore that's become 5 multiplied 3 multiplied 2. And here is this can be written as ln 2 power 3. Now that we use exponent rule in this, coefficient become power. Now 2 power 3 plus ln 3, and that is equal to ln 30. Now that value become ln 8 plus ln 3. Now this ln 30. Therefore, ln 8 plus ln 3, we use a product rule. In this rule, ln x plus y can be written as ln x multiply y. Therefore, x into ln 8 multiplied 3, and that is equal to ln 30, and that is ln 24 will be equal to ln 30, and that is equal to x equal to ln 30 over 24. ln 30 over ln 24. This is the answer. Question 2, the polynomial 2x power 3 minus x square plus a, where a is a constant, is denoted by p of x. It is given that 2x plus 3 is a factor of p of x. Find the value of a. Now you see here the polynomial is p of x is equal to 2x cubed minus x squared plus a. Now 2x plus 3 is a factor of p of x. We use the remainder theorem. In the remainder theorem, if x plus a is a factor, if x plus a or factor of p of x, then p of x will be equal to p of a will be equal to 0. Therefore, 2x plus 3 is a factor of p of x. Therefore, we can write it as 2x plus 3 equal to 0. That's equal to x equal to minus 3 over 2. And that is equal to a is equal to minus 3 over 2. We write it minus 3 over 2 equal to 0. Now we substitute the value in this polynomial x equal to minus 3 over 2 p of minus 3 over 2. Therefore, 2 into minus 3 over 2 whole cube minus x square is written minus 3 over 2 whole square plus a, and that's value p of minus 3 is 0 because px 2x plus 3 is a factor. Now we can write it as minus 3 square is a minus 27. This minus 27 over 8, and minus 3 over 2 whole square is 9 over 4 plus 9 plus 8, and that is equal to minus 27 over 4 minus 9 over 4 plus a, that will be equal to minus 36 over 4 plus a equal to 0. That's equal to 0 equal to minus 9 plus a. Therefore, a will be equal to 9. This is the answer. Okay. Question 2, part B. When a has this value, solve the inequality p of x is less than 0. Now you see here, this is the polynomial 2x2 minus x squared. The value of a is 9. That is less than equal to 0. We know 2x plus 3 is a factor of this polynomial. Therefore, we can write it as 2x plus 3 into. Now the second factor can be written as x squared plus p of x plus q, that is less than 0. Firstly, we find the p and q value. Now you see here we can write it as 2x plus 3 into x squared plus px plus q, that is equal to 2x cubed minus x squared plus 9. Now we multiply it, we get 2x cubed plus 2px squared plus 3x squared, 2, 2x plus 2, 2x plus 3x squared and plus 3px and plus 3q, that is equal to 2x cubed minus x squared plus 9. Now comparing the coefficient of x square and constant. X square and constant. You see here the coefficient of x square is 2p and 3. Now there is coefficient of x square is 1. We can write it as 2p plus 3 equal to minus 1. Therefore, we can write it as minus 4, 2p equal to minus 4, then p will be equal to minus 2. Same as here, coefficient of x, constant. You see, the constant is 3q plus 9. This is the constant, 3q, and here is 9. Therefore, we get 2 equal to 3. Now, this expression will be 2x plus 3 into x squared plus minus 2x plus 3. That is less than 0. Now, this factor is a quadratic expression, and when we see that the roots of this quadratic function, firstly we check this root, x squared minus 2x plus 3. You see here, if you take the discriminant b square minus 4, you see that will be equal to minus 2 whole square minus 4 into 1 into 3, that's equal to minus 8, and that is less than 0. Therefore, the roots of above expression is not real. Therefore, x square minus 2x plus 3 less than 0, not possible, and 2x plus 3 is less than 0. Take this inequality, that value will be equal to minus 3 over 2, and this is the answer. Question 3, the equation of the curve is y equal to sine x into sine 2x. The curve has stationary points in the interval. Find the x-coordinate of the point. Now you see here, this is the equation of the curve, y equal to sine 2x, sine x into sine 2x. Now to find the stationary point, we take the derivative of this curve. The derivative of this curve dy over dx will be equal to for the stationary points. Therefore, we take the derivative of this curve. Firstly, we simplify this curve. Here we can write it as sin x can be written as sin 2x can be written as 2 sin x cos x to 2 sin square x into cos x, and 2 sin square x into cos x can be written as 1 minus cos square x into cos x. You know the sin square x equal to 1 minus cos square x. Therefore, I substitute the value here. Now to multiply this 2 cos x minus 2 cos cube x, that is equal to y. Now we take the derivative. Dy over dx will be equal to the derivative of cos x, you know, minus sin x. Now we write it minus 2 sin x, and minus, you see here 2 is written as it is, and the derivative of cos cube, firstly we take the derivative of this power, not the 3 cos square x, and then derivative of this base will be minus sin x. Therefore, that value will be equal to minus 2 sin x plus sin x 6 sin x into cos square x. Now we can write it as dy over dx is equal to 0. We take the derivative dy over dx equal to 0 for stationary point. Therefore, dy over dx 0, we can write it as minus 0 equal to minus 2 sin x plus 6 sin x cos square x. Now we take the common sin x minus 2 sin x as a common, we get 1 plus 1 minus 3 cos square x equal to 0. Now we can write it as 1 minus 3 cos square x equal to 0 either, or minus 2 sin x equal to 0. You see here that cos square x will be equal to 1 over 3. That cos x will be equal to square root of 1 over under root 3 plus minus. Now the alpha will be equal to cos inverse 1 over square root 3. Firstly, we take the basic angle. Now the basic angle is, now the alpha will be equal to 0.955. You can write it as there 0.96 is the answer. Now we see here the angle is between 0 to x is, the angle x is 0 to pi over 2. It means the angle lies on only in the first quadrant. Therefore, that value alpha equal to theta. Therefore, we write it as x will be equal to alpha, and alpha is 0.96, and we take only the positive value because it lies in the 0 to pi over 2. Now to go to the next part. Question 4, part A, express 4 cos x minus sin x in form r cos x plus alpha r is greater than 0. Now we can write it as 4 cos x minus r minus sin x can be written as is equal to r cos x plus alpha. Now this right hand side can be written as r Now we use the formula cos alpha plus beta here, and this formula is also given in your formula sheet. Now we can write it as cos x cos alpha plus minus sin x sin alpha sin alpha. Therefore, we can write it as r cos x into cos alpha minus sin r sin x into sin alpha. Therefore, you comparing the coefficient of cos and sin x. You see here the coefficient of cos x is 4 and here is r and cos alpha. And the coefficient of sine is minus 1 and here is the minus r into sin x. Now we write it as 4 equal to r cos alpha and minus 1 equal to r sin alpha. Okay. Now we name it equation 1 and equation 2. Now we take the square of both equation. We get 4 square is 16 and r square cos square alpha, and then that is 1 and r square sin square alpha. We add these two equations, we get r square cos square alpha plus sin square alpha, that is equal to 16 plus 1, and that is equal to 1, and r square into 1 equal to 17, and therefore we can write it as r will be equal to square root of 17. Now next is the find the angle. Firstly we find angle. You can see here the question 2 is divided by question 1. We divide equation 2 divided by equation 1. Therefore, we get r sin alpha, our r cos alpha will be equal to 1 over 4. Therefore, r will be cancelled and tan alpha will be equal to 1 over 4. Therefore, we can write it as alpha will be equal to tan inverse 1 over 4. And this is the answer. Now the alpha equal to 14.04. Now we write it as equation 4 cos x minus sin 2x minus sin x. That's equal to r is square root 17 into cos. You see here x plus alpha. There is x. Alpha is 14.04. Now the part B. Solve the equation 4 cos 2x minus sin 2x equal to 3. You know 4 cos x minus sin x equal to square root of 17 into cos x plus 14.04. Now the x is here is 2x. Therefore, we can write as 4 cos 2x minus sin 2x equal to square root of 17 into cos 2x plus 14.04. Okay. Now that's left hand side equal to 3. Now we can write it square root of 17 into cos 2x plus 14.04 is equal to 3. That is 2x plus 14.04 equal to cos inverse 3 over square root of 17. Now this value is 2x plus 14.04. Well, we take basic angle alpha. Alpha will be equal to cos inverse square root of 3 over square root of 17. Now we take the value. Here the angle is 43.31. The angle is 43.31. You see here the interval is given, x is 0 to 180 degree. X is between 0 to 180 degree. Now when we take the angle 2x, the interval becomes 180 multiplied 2 is 360 degree. Therefore, the angle, we will take the value of x between 1 and 4th quadrant. Now when we take the value in the first quadrant, and the value in the first quadrant will be theta equal to alpha. Now we can write it 2x plus 14.04 equal to 43.31, and that value will be equal to x equal to 43.31 minus 14.04 divided by 2. Now 14.31 minus 14.04, that's equal to 29.27 divided by 2. The answer is 14.63 is the answer. And next value you will take in the fourth quadrant. In the fourth quadrant, the value will be equal to, you see here, this is this alpha will be lying in the fourth quadrant, then the angle theta will be equal to 360 minus alpha degree. This is 360 minus alpha, therefore we can write it 2x plus 14.04 equal to 360 minus 43.31, and you can write it as 2x will be equal to 360 minus 43.31 minus 14.04, and divided by 2 you get the value of x. Now we calculate it. 260 minus 43.31 minus 14.04, and that is equal to 302 divided by 2. The answer will be equal to 151.3, and this is the second angle, and this is the answer. In the question 5, part A, solve the equation z square minus 6iz minus 12 equal to 0. The answer in the form x plus iy, where x and y are real numbers. You see here, this is the quadratic equation. You can find the roots of z by quadratic formula. Therefore, z will be equal to minus b. Here is b is minus 6i plus minus b square minus 4ac. b is minus 6i whole square minus 4 times a is 1, c is minus 12, and our 2a, or you can write it 2 into 1, and therefore that value becomes 6i plus minus 6i square is minus 36 minus minus plus 12 4 are 30, 12 4 are 48 over 2, and that can be written as, now you can write it as 6i plus minus 48 minus 36 is 12. Therefore, we can write it as 6i plus minus 2 under root 3. The square root of 12 can be written to square root 3 over 2, and that is equal to 3i plus minus square root 3. Now we can write it g is equal to plus minus square root 3 plus 3i, and there will be two roots, that's equal to plus under root square root 3 plus 3i, and then second is minus and square root 3 plus 3i. Okay. Now the part B. On sketch of an organ diagram with origin, show the points A and B representing the roots of the equation in part A. Now, to mention the points A and B, firstly we draw our graph here. We draw two axes. One is real axis, one x-axis is real axis, that is real axis, and the y-axis is imaginary axis. Now you see here the points of this complex number is square root 3 into 3, and second point is minus square root 3 into 3. Now we mention the points here. Number 1, this is 1, 2, and 3. And same as minus 1, minus 1, minus 2, minus 3, and 1, 2, and 3. You see here square root 3, that value is approximately equal to 1.7. Now we'll mention this point is square root 3, and that is square root minus 3. You see here this is 1, 2, and 3, and we mark the point square root 3 into 3, that is the point. This is the point A, and same as on this axis, minus square root 3, 3, this point will be minus square root 3. This point is A, and this point is, and this is the answer. Part C, find the exact modulus and argument of each root. Now we have root the equation R, Z1 is equal to square root of 3 plus 3i, and second root is Z1 is equal to minus square root of 3 plus 3i. Now to find the modulus, we take the modulus of Z1, that will be equal to square root of x square plus y square. Now here is the x value is square root 3, and we take the square. And second is y is 3, and we take the square. Now the square root of these two values, we find it. That value will be equal to 3 plus 9 square root, and that answer is square root 12. And same find the modulus of Z2. This is the Z2. Now we take the modulus. Now that value will be equal to minus square root 3 whole square plus 3 whole square, and that will be equal to 3 plus 9 square root, and that is the answer is that 2 is also square root 12. Now the argument of this root, the argument of that one will be equal to y over x. Now you see here the y is positive 3 over square root 3. Now tan inverse 3 over tan inverse y over x. The formula is tan inverse y over x. So we find the value tan inverse 3 over square root 3, and that is the argument C1, Z1. Now we find the basic angle value. Now the basic angle of tan inverse 3 over square root 3, the answer is tan inverse 3 over square root of 3 is 5 over 3. Okay, now we write it 5 over 3 is the. Now this angle lie in the first quadrant, therefore theta will be equal to alpha. Now we can write it as argument E will be equal to alpha, and that is equal to 5 over 3. Now in second case, we see here the argument G2 will be equal to y over tan inverse y over x. tan inverse y over x. You see here y is minus 3 over and x is square root of minus 3. Now the alpha will be equal to tan inverse basic angle will be equal to 3 over under root 3 and that will be equal to also pi over 3. But this root lie in the second quadrant. You see here this lie in the second quadrant because x is negative. Therefore that is lie in the second quadrant. Therefore argument g will be equal to pi minus alpha. Therefore, we can write it pi minus pi over 3. That value will be equal to 2 pi over 3 and this is the answer. And show that the triangle OAB is an equilateral triangle. Now we draw the points of the triangle A and B. Now we here draw a graph. We take two axes. One is real and imaginary axis. This is the x-axis is real axis and y-axis is imaginary axis. Now we mention the coordinates. This point is O and the point is 1, 2, 3 and same here is -1, -2 and -3. Now we write here is the point 1, 2 and 3. Now you see here this value will be equal to square root of 3 and that will be equal to 3. Now we mark the point. And here is minus square root of 3 and 3. And these are the points A and B. And these are the roots of, and this is the first root, that one, and we mention it here. This is the Z1 and that is Z2. Now you see the argument of Z1 is, this is the argument of Z1, this is the argument of Z2. The argument of Z1, this is pi over 3. Okay, the argument of Z2 and this angle is 2 pi over 3. 2 pi over. Now the angle between AOB, this angle will be equal to 2 pi over 3 minus pi over 3. Therefore we can write it, the angle AOB will be equal to 2 pi over 3 minus pi over 3. You see here that's equal to pi over 2. Now the angle is between AOB is pi over 3. You see here this AO and OB lengths are equal because that value is square root of 12. Now therefore OA will be equal to OB. OA equal to OB and that is, we join this AB. This is the isosceles triangle OA equal to OB, and therefore we can find the angle OAB angle equal to angle OBA. We name it, this angle is as suppose name is P degree. Now we name it P, that's angle equal to P. Now we find the angle P. First you see here this is the base side. The angle of the angle on base sides always equal in isosceles triangle. You see here this is the base of isosceles triangle, therefore T degree will be equal to T degree. Therefore we can write it 2T degree plus pi over 3 equal to 180 equal to pi. Now 2T will be equal to pi minus pi over. Therefore that will be equal to 2 pi over 3, 2T equal to pi. Pi over 3, that will be equal to pi over 3. Now you see here the angle OAB equal to angle OBA, that's equal to pi over 3. And you can see here the angle AOB is already is pi over 3. Therefore, each angle in a triangle are equal. Each angle in triangle are equal. If three angles are equal in a triangle, that triangle will be called equilateral triangle. So hence, AOB is equilateral triangle. Equilateral, equilateral triangle. And this is the derivation of equilateral triangle AOB. Now to go to the next question. Question 6. Relative to the origin, the points A, B, and C have the position vectors given by OA equal to 1, 3, 1, OB equal to 3, 1, 2, OC equal to 5, 3, minus 2. Using scalar product, find the cosine of angle BAC. Now we suppose that this is the angle A, OA, and this angle is, now we name it as angle AB. This angle is named as AB and this angle is named as AC. Now we take the dot product between AB and AC. The dot product between AB dot AC, that will be equal to AB magnitude into AC magnitude into cos the angle between them, that is cos angle BAC. You see here you have to find the cos angle BAC. Therefore we can to find the cos BAC, firstly we have to find AB dot AC. Now firstly we find AB. Now to vector AB equal to OB minus A. And the vector OB will be equal to, that's vector OB, 3, 1, 2, and OA is 1, 3, 1. Therefore, OB minus OA will be equal to 3 minus 1 is 2, 1 minus 3 is minus 2, 2 minus 1 is 1. And same as we find the AC, AC vector will be equal to OC minus OA. You can write it as OC vector is 5, 3, minus 2. And OA vector is 1, 3, 1. Now the difference between them is 5 minus 1 is 4, 3 minus 3 is 0, minus 2 minus 1 is minus 3. Now this is the AC vector and this vector is AB. Now you will take AB dot AC. AB dot AC will be equal to, you see here AB is 2, minus 2, 1, and AC is equal to 4, 0, minus 3. Now the product of between AB dot AC will be equal to, this is x1, y1, z1. This is x2, y2, z2. Now we multiply corresponding x coordinate. x1 into x2 is 2 multiply 4. You can write it x1, x2. And same as y1, y2. y1, y2 minus 2 multiply 0. And next is plus z1, z2. 1 multiply minus 3. The answer is 8 minus 3, that is equal to 5. Now next is we have to find AB, modulus AB. Therefore this value will be equal to x square plus y square plus z square. That's x is 2 square plus minus 2 whole square plus 1 whole square, and take the square root. That answer will be equal to 2 plus 2 square 4 plus 4 8 plus 1 9, and square root of 9, that is equal to 3. And next is AC modulus. Now AC modulus will be equal to, you see here AC is 4, 0 minus 3, therefore 4 square plus 0 square plus minus 3 square whole square. Now we take the square root, that is equal to 4 square is 16 plus 9, 25, and that is equal to 5. Now the answer is 5. Therefore, cos of BAC, cos of angle BAC will be equal to AB dot AC, our AB magnitude, our AC magnitude. This formula is also given in the formula sheet. Now you substitute the value AB dot AC. You see here AB dot AC is 5 and AB magnitude is 3. AC magnitude is 5. Therefore, the answer is 1 over 3 cosine of angle BAC, 1 over 3. And this is the answer. Part B, hence find the area of triangle ABC. Give your answer in simplified exact form. You see here that is AC, and this vector is AB. We can join these two vectors, that is AB and C. We see here the cosine of BAC, cosine of BAC is equal to 1 over 3. Now the angle of BAC will be equal to cos inverse BAC, 1 over 3. Now we calculate this angle. Now cos inverse 1 over 3 is equal to 70.5 degrees. Now to find the area of triangle, we use the formula 1 over 2. Area of triangle will be equal to 1 over 2 product of the adjacent sides AB multiplied by AC and the angle between them. This is the angle sine BAC. Now here is the 1 over 2 and the length AB. Length AB is 3 and AC is 5. We already calculated this value in the previous part. Now that is equal to 3 into 5 into sine. Angle between them is 70.5 degrees. When we multiply 3 multiply 5 multiply sine 70.52, the answer is 14.14. Now divided by 2, we see here is the answer is 7.07 is the answer. 7.07. Question 7, variable x and theta satisfy the differential equation, and this is the differential equation, and it is given x equal to 2 and theta equal to 5 or 4, so that d over d theta into cot square theta equal to minus 2 cot theta over sine square theta. Now you see here d over d theta equal to cot square theta. Now we take the derivative and we use the formula of, here is the f of x power n d over dx, that will be equal to fn into f of x power n minus 1 into f dash of x. Now you see here that value will be equal to 2 cot theta into derivative of cot theta. The derivative of cot theta, 2 cot theta is written as it is, and the derivative of cot theta is minus cosecant square theta. Minus cosecant square theta. Therefore, that value is minus 2 cot theta into cosecant square theta, and cosecant square theta can be written as 1 over sine square theta. Minus 2 cot theta into 1 over sine square theta. And this is the proof. The left hand side of this equation equal to right hand side. Okay. Now go to the next part B. Solve the differential equation. Find the value of x when theta equal to pi over 6. Now this is the differential equation. And to solve this differential equation, we separate the x and theta variable. There is the x sine square theta can be written as x into dx, and that is sine square theta over d theta, and this there is the tan square theta minus 2 cot theta. Now that it will be equal to x dx will be equal to tan square theta minus 2 cot theta, and sine square theta will be divided on both terms. Now that is sine square theta, and d theta they will shift from left to right side. Now this x into dx, that side will be equal to tan square can be written as sine square theta over cos square theta into 1 over sine square theta, and minus that's 2 cot theta over sine square theta d theta. Now here is the sine will be cancelled. 1 over cos square, that is equal to secant square theta minus 2 cot theta sine square theta d theta. That's dx. Now we take the integration. We integrate both sides. That's the x dx will be equal to integration of this secant square theta into d theta minus integral of minus 2 cot theta over minus 2 cot theta over sine square theta d theta. Firstly, secant square theta is equal to tan theta. Integration of secant square theta is tan theta. Now the integration of x dx will be equal to x square over 2. Now the integral of minus 2 cot theta, now we can write it as plus minus 2 cot theta over sine square theta into d. Now we integrate it minus 2 cot theta d theta over sine square. You know d over d theta will be equal to d over d theta into cot square theta. That's equal to minus 2 cot theta over sine square theta. Now we integrate it. If we integrate this value minus 2 cot theta sine square theta d theta, that will be equal to cot square. Therefore, we can write it as cot square theta. Now we substitute this value in equation. This is equation 1. We name it. Now we put the value here. That will be equal to x square over 2. That's equal to tan theta plus cot square theta. Now the theta is equal to pi over 6 is given in the question. Now we can put the value and find the x. Now you see here that is equal to 10 pi over 6 plus you can write it 1 over 10 pi over 6 whole square, and that is x square over 2. You see here the 10 pi over 6 plus 1 over 10 pi over 6. Now we take the value of 10 is 10 pi over 6 is square root over 3. Now we write it here under root 3 over 3. And same here is the value is plus 1 over square root 3 over 3 whole square. Now that value will be equal to x square over 2, and that can be written as square root of 3 over 3 plus that value will be equal to 1 over 3 over 9, and that is equal to under root 3 to over 3 plus 3. Now this therefore x square will be equal to 2 square root 3 over 3 plus 3. Now we calculate this value. Now the x square equal to 2 bracket square root over 3 plus 3. The answer is 7.14. 7.154. Now we take the square on both sides. That value will be equal to, now we take square root. So this is the 2.67 is the answer. In question 8, the diagram shows part of the curve y equal to square root of x. This part of the curve intersects the x-axis at the point x equal to a. State the exact value of a. Now you see here, this is the y equal to sine under root x. Now you see here the curve intersects the x-axis, therefore y is 0. We can write it 0 sine square root x. The next will be square root of x will be equal to sine inverse 0, and the sine inverse 0 under root x will be sine inverse 0 at x equal to 0 or either x equal to pi. Square root of x equal to pi. Therefore, we can write it as x will be equal to pi square. Here is x is a. Now you see here is a. Now a equal to pi square, and that is x equal to 0, and that is equal to 0. Therefore, the exact value of a is here. That value will be pi square because that is 0. Now we have to find this value. Then the answer is pi square. Now the next part. Using the substitution u is equal to under root x, exact value of exact area of the shaded region in the first quadrant bounded by this curve of the curve and the x-axis. Now the area of the shaded region under this curve, that is equal to area of shaded region integration of y dx. Now we can write it as integral of sine square root x into dx. You see here the interval is 0 to pi square. We write it as 0 to pi square. Now to using substitution method. Now here if we suppose the u equal to square root x. Therefore du over dx will be equal to 1 over 2 x power minus 1 over 2, and that is can be written as du will be equal to 1 over 2 square root of x dx, and dx can be written as 2 square root of x du, and x is u. Now therefore dx will be equal to 2u du, and same here x equal to, here is x equal to 0, then you know u will be equal to under root x, and u will be equal to under root u equal to 0, and the second limits when x equal to 5 square, then u will be equal to under root x and u will be equal to square root of 5 square, then u will be equal to 5. Now we substitute the value here y, now the 0 to 5 square, that becomes 0 to, that is 0 to 5. And here is the area of division of sine as written as it is. Square root of x is u sine u into dx. Dx is 2u into du. 2u into du. Now this can be written as 2 into sine u into sine u, u into sine u du. Now we simplify it by using the product rule of integration. We use the product formula, that's the g of u into f dash of u, that's equal to g u into f u minus g dash u into f u du. Now this formula is also given in your worksheet. You can, now the first term is considered as u because this is the algebraic value, and second is the trigonometric value. We use the priority rule. The priority rule, you can use the term LAT, this is the short term you can use for priority. Now you see here I means the inverse function, L means the logarithm function, A is the algebraic function, and T is the trigonometric. Now we take the, firstly we take first value, first term is taken as algebraic value, value. You see here the algebraic is u. Now we can write as p of u is equal to u, and f dash of u is written as sine u. This is equal to sine u. Now we find the value of g dash of u, that is will be equal to, we take the derivative, that is equal to 1, and f dash of u we take the integration, that is equal to f of u will be equal to minus, and when you take the integration, that will be equal to cos u. Okay, now the sine u, that's the integration of sine u is minus cos u. Now we substitute the value in this equation, in this formula you see here. Now the put the value in g of u, we write it as u into sine u into du, and that will be equal to d of u is u, and f of u here is minus cos u. You can write it as minus cos u minus, written as it is, g dash of u is 1, and f of u is minus cos u into du. Now this value will be equal to minus u cos u minus minus plus integration of cos u into du. That value will be equal to minus u cos u, and you take the integration of cos u. So integration of cos will be equal to sine, and that's equal to plus sine u, and this is the integration of u into sine u. Now the limits is 0 to 5. Now we put the value here as 0 to 5, and that is 0 to 5. It's equal to 0 to 5, and that is 0 to 5. And we can write it as 0 to 5 value. Now we see here what value is equal to, now minus u into cos pi plus sine pi. Yes. Now we put the lower limit value, minus 0 into cos u is 0, and sine 0. Now you see that here is the minus 2 is, now here is minus 5 into cos pi plus sin pi. You put the value minus pi, you, the value of 2 is 5, then is cos pi and plus sin pi minus 0 into plus sin 0. Now we can write it minus pi equal to cos pi is minus 1 and sin pi is 0, and this is 0 plus 0. Now that value equal to 5, and here is this value is put in this equation 2 into 0 pi u sin u. Now we put this value. Now here is area will be equal to 2 into 0 pi u into sin u into du. That value will be equal to 2 into, and that is equal to 5. Now we write it 5. This is the 2 pi is the answer. Question 9. The diagram shows the semicircle with the diameter AB with center O and radius R. The shaded region is the minor segment on the chord AC, and its area is one-third of the semicircle. The angle CAB is in theta radian. Show that theta equal to 1 over 3 pi minus 1.5 into sine 2 theta. Here the condition is given: the shaded area region of minor segment is one-third of the area of semicircle. Now we can write it as area of semicircle, and the area of shaded region, area of shaded region, and that area is one-third of this area of semicircle. Therefore, to equalize this, we multiply this area of shaded region by 3, and now we find the area of semicircle is, we know the formula of area of semicircle is pi r square over 2. Now here is the area of shaded region will be equal to area of sector AOC minus area of triangle AOC. Now you see here area of sector, that formula is equal to theta over 1 over 2 r square theta. In radian, this formula is 1 over 2 r square theta minus area of triangle 1 over 2 product of the adjacent side into sine of angle between them. Now the adjacent side is AO and OB. Now we can write it r square into sine theta. This is the formula. Now we put here the firstly we find the angle theta. You see here OC and OA lengths are equal. Therefore, this AC is base side and the angle on base sides always equal. You can write it as theta. Therefore, this angle will be equal to pi minus theta, that is equal to pi minus 2 theta. Now, therefore, theta is pi minus 2 theta. Now we write it as pi r square over 2 equal to 3 into 1 over 2 r square into pi minus 2 theta minus 1 over 2 r square into sine pi minus 2 theta. Okay, now we simplify it. Pi over r square over 2 equal to 3 over 2 pi r square minus 3 over 2 into r square 2 theta minus 3 over 2 r square sine pi minus 2 theta. You know pi minus 2 theta, pi minus theta equal to sine pi minus theta equal to theta, sine theta. Now you can write it sine theta. Therefore, you can write it as sine pi minus 2 theta, that is equal to sine 2 theta. Now here is the pi over 2, 3 over 2 is taken as a common, 3 over 2 r square is a common. Now that value will be equal to pi minus 2 theta minus sine 2 theta, that is equal to pi over 2 r square. Now this value will be cancelled. Now that's equal to pi equal to 3 pi minus 6 theta minus 3 sine theta sine 2 theta. Now 6 theta will be equal to pi will be shift from left to right side, 2 pi minus 3 sine 2 theta. Now the theta will be equal to 1 over 3 pi minus 2 over 6 is 1 over 3 pi minus 1 over 2 sine 2 theta. Now we can write it as 3 over 3 because we can write it 3 into 3 over 3. That 1 over 3 is taken as a common. That value will become pi minus 3 over 2 3 over 2 sine 2 theta. That value will be equal to 1 over 3 into pi minus 1.5 into sine 2 theta. Now here it's multiplied by 3 numerator and denominator to take 1 over 3 as a common. Therefore, we can write 3 over 2 sine 2 theta. This is the answer. You see here, verify by calculation that theta is greater than 0.5 and theta is less than 0.7. Now we put that theta is equal to 0.5. You see here that the function will become 1 over 3 pi minus 1 over 1.5 into sine 2 into 0.5. Now the value of theta will be equal to, now we see here value, that value will be equal to 0.63. You see here when we put the value sine 1 over 3 into pi minus 1.5 sine into 2, 0.5. The answer is 0.63. 0.63. Now you put when the value theta is equal to 0.7, that value will become 1 over 3 pi minus 1.5 into sine into 2 into 0.7. Now the value of, now we put the value 0.7 here. Therefore, the value becomes 0.55. Now it is equal to 0.55. Now that value is greater than 0.5. You see here when theta is 0.5, the value is 0.63. And when theta is 0.7, that value is less than 0.7. Now therefore, that's verify that the theta in between 0.5 and 0.7. Now you see here the f of theta is equal to theta minus 1 over 3 pi 1 over 3 pi minus 1.5 sine 2 theta. Now you can calculate you can find uh, the root of this function. Firstly, we put the 0 f of 0.5. We see here the 0.5 minus 0.63. The answer is less than 0. Now you see here, if you put 0.7 in this equation, now 0.7 minus 0.55, this is the value of theta here you see. That is f of theta can be written as 0.7 minus 0.3 is greater than 0. Therefore, the root will lie in between 0.55, 0.5 and 0.6. 0.5 to in between to 0.7. The root will lie in this interval. Root lies in interval. In the interval 0.5 to 0.7. In the next part, you see here use an iterative formula based on the equation of part A to determine the theta correct to 3 decimal places. Give the result to each iteration into 5 decimal places. Now you see here this is the f of theta that is equal to theta minus 1 over 3 into 5 minus 1.5. Theta will be equal to theta will be equal to 1 over 3 pi minus 1.5 into sine 2 theta. Now to make the equation formula, we write it as theta n plus 1 and that is equal to sine theta. Now the initial value of the root, we take the value in between 0.5 to 0.7. That value, initial value we take is theta 0 is taken as 0.6. The middle value of between 0.5 and 0.6. Now to find the theta 1, firstly we find theta 1. That value will be equal to 1 over 3 into 5 minus 1.5 into sine 2 into theta 0. Now next value will be equal to the same as theta 1, theta 2. That value equal to 1 over 3 into 5 minus 1.5 into sine 2 theta 1. Now we see that when we substitute the values, theta 0, here is the theta 0, 0.6. Now we can write it as 1 over 3, 5 minus 1.5 into sine 2 multiplied 0.6, 0.12. Now we calculate it. You see here the answer is 0.1 over 3 pi minus 1.5 sine into 2 into 0.6. The answer is 0.5811. Now we can write it as 0.5811. Now we can calculate this other values theta 2, theta 3, theta 4 and theta 5. All these values unless the values become same. Now this for you can calculate it by using the formula here. In this formula we can write it as, now we write the formula. Now here is the formula. This is the answer. Now we write the formula 1 divided by, you see here we can use this formula in the calculator. 1 over 3 pi minus 1.5 into sine 2 into answer. Now you can see here the answer is 0.5855 and next answer is, I press it, then this is the theta 2 and that is theta 3 will be equal to 0.5866 and 5866 in next is 0.5861. You see here if next the third decimal place 0.586 and repeat this value. Now you can see here 0.586. Now these values we can write it as there. First is theta 3 is theta 2 is 0.588 and 3 and next is 0.5855. Now the other values are Q4 is 0.587, Q5 is 0.5861, that becomes 0.586, and the Q6 is 0.5863 equal to 0.586. You see here these two values are same and the next other values will also 0.586, and therefore this is the answer of the equation. And go to the next question. Question 10, let f of x equal to 4 minus x plus x square over 1 plus x into 2 plus x square. Express f of x in partial fractions. Now this is the fraction 4 minus x plus x square over 1 plus x plus 2 plus x square. And in this fraction, the denominator having 1 is linear and other is the quadratic function. Now, in the partial fraction, we resolve the fraction into two or more than two fractions. Firstly, we see that here is the two factor given in the denominator. One is linear, 1 plus x. Other is the quadratic, that is named as x square plus 2. Now, that is the for linear denominator. When the denominator is linear, the numerator is stored that as a constant number a. And now you see here the denominator is quadratic, therefore the numerator will be supposed as bx plus c. Now we simplify it. Now we multiply this fraction by denominator a 1 plus x plus into 2 plus x square, multiplying by 1 plus x into 2 plus x square. Therefore, we get 4 minus x plus x square equal to a into 1 plus x will be cancelled, and 2 plus x whole square will be will remain. And next is the bx plus c is written as it is into x square plus 2x square plus 2 will be cancelled. 1 plus x is written. Now we see here to find the factor a, we suppose that x plus 1 equal to 0, that is x equal to minus 1. Now for x equal to minus 1, we see here the 4 minus, that is x, sorry, 4 minus 1 plus minus 1 whole square equal to a into 2 plus minus 1 whole square plus b into minus 1 plus c and minus 1 plus 1 minus 1. Now you see here that is equal to 4 plus 1, and that is equal to plus 1, and that is a equal to 2 plus 1 is 3, and this at that value becomes 0, and therefore a will be equal to 6 over 3, and that is a equal to 2. Now to find the value of b and c, we suppose that we take some values of x and we suppose let x equal to 0. Now when x equal to 0, that's equal to 4 minus 0 plus 0. Therefore, a will be equal to 2 plus 0 and b will be equal to b into 0 plus c and 1 plus 0. Now you see here that is 4 equal to 2 of a is, now the value of a is 2. Now can write it 2 multiply 2 plus c will be 3 into 1, and therefore 4 minus 4 c will be equal to 0. Now we take another value, suppose that we take x equal to 2. Now in this x we substitute the value in equation, this is equation name is 1. Now we put here is x equal to 2. Now 4 minus 2 plus 2 square will be equal to a into 2 plus minus 2 square plus b into 2 plus c 0. Now here is next x is 2, 1 plus 2. Now that's value equal to 4 plus 4 is 8 minus 2 is 6. That is equal to a is 2. Now I can write it as 2 into 2, 4 2 it is a 4, 4 plus 2, 4 plus 2 is 6. Now plus that's equal to 2b into 3. Now that will be equal to 6 minus 12, and that is equal to 6b, and b will be equal to minus 6. That's equal to minus 1. Now the partial fraction, you see here this is the fraction, and we can write it as 2 over x plus 1 minus b is minus 1 minus 1x plus c 0 and x square plus 2. And this the partial fraction you have. Now you see here the fraction was 4 minus x plus x square, 4 minus x plus x square over x plus 1 into 2 plus x square, and this is the answer, 2 over x plus 1 minus x over x square plus 2. Now go to the second part of this question. Part B, find the exact value of 0 to 4 f of x dx. Give your answer as a single logarithm. Now you see here, this is the function f of x. Now we take the integration of this function. Now we start it. Here we integrate it. This f of x, the f of x equal to 4 minus x plus x square over x plus 1 plus 2 plus x square. Now in integration 0 to 4, that function can be written as, that is the fraction is written as 2 over x plus 1 minus 1 minus 1x. Now we integrate it, that's equal to dx. Dx here is 0 to 4. Now we use the, to integrate this 2 over x plus 1, we use the integration formula of 1 over x, 1 over f of x, that will be equal to ln f of x. Therefore, we can write it as 2 is written as it is 1 over x plus 1 integration of this, that will be equal to ln x plus 1 and 0 to 4. And same here is as we see here 0 to 4x plus over x square plus 2. The formula is f dash of x dx into ln f of x. And this is the main formula. Now we see here the differentiation of x square plus 2 is 2x. We can write it as minus 1 over 2 into 2x, and therefore x square plus 2 into dx. Now we can apply here is the this logarithm formula of integration. Now you see here the integration of f dash of x over f of x is ln f of x. Therefore we can write it as minus 1 over 2 ln x square plus 2, and take the limit 0 to 4 here. We substitute it 0 to 4. Now here is also now 2 into ln x plus 1 0 to 4. Now we apply the limits, and now this value will become ln 4 plus 1 is 5, and minus ln 0 plus 1, and the second value will be minus 1 over 2 ln 4 square is 16 plus 2 is 18 minus ln 0 plus 2. Now that value will be equal to 2 ln 5 minus ln 1 is 0. We can write it as 0 minus 1 over 2 ln 18 minus minus plus 1 over 2 ln 2. Now we can write it as ln 5 square minus ln 18 square root plus ln square root of 2. We use the logarithm rule of exponential logarithm rule, in which the ln x power a can be written as a into ln x. Here the coefficient become power. Now we use the product rule. In this rule, we see here the ln25 multiply square root of 2 over square root of 18, and that is will be equal to ln25 over square root of 9, and that is equal to ln 5 over 25 over 3. This is the answer ln 25 over 3.